By way of background, I wanted to describe our company. We're relatively new, although the principals in the company have done about 250 projects in the past, valued at about $2 billion. We have about $1.5 billion that we've raised from Denham Capital Management to go off in search of projects that will capture what is currently waste at industrial facilities across the country, reducing their costs, hopefully making them more productive and more competitive, and at the same time our overall goal is to reduce greenhouse gases. Sort of an overview, and Jackie was sort of starting on this, I think the climate change debate is totally skewed, or at least it has been to date. On the one side you have most of the environmental groups, fortunately not EDF, that are out there saying the reason that you have to cut back carbon emissions is for moral purposes. Otherwise the planet will destroy and our grandchildren will die. And on the other side, you've got the Chamber of Commerce's and others who are saying, well, that's nice, but it's going to cost a lot and jobs will be lost. That's not the debate. The debate should be, how can we cut greenhouse gases and make a profit doing it? And there are tons and tons of ways to do that. The amount of energy waste in our country is just vast. And I'll try and show you, particularly in the industrial sector, it's really quite amazing. So I think you can increase both efficiency and productivity, and as a result you'll have both jobs and reduce pollution. How much waste is there in the energy system? Most of us, at least in the policy junkies, when we think about efficiency we think just about demand side. Better lighting, more insulation, better appliances, and those are critical. Absolutely critical, but I would suggest there is an enormous waste in the generation side, in the production of both heat and power. And it'll come back, basically about 2/3 of carbon emissions in this country result from the production of electricity and heat. So how much waste is there? You know, oddly enough, policymakers I don't think get it. But you ask any school kid to draw a picture of what a power plant looks like, and you get this. This is Homer Simpson's. What's the, most people don't watch The Simpsons? I have a kid, we watch it all the time. What's the big thing here? This, gargantuan plumes. You know what those plumes are? Heat. That heat is being vented. Vented means waste. And I don't think most people sort of realize that the amount of waste in our electricity system, we spend 3 units of fuel to get 1 unit of electricity. This is the cartoon picture. That's the reality. This is a power plant in Craig, Colorado. 2/3 of the electricity is lost. The efficiency of electricity production in this country has been at 33% since Dwight Eisenhower was in the White House. It has not increased 1 percentage point in 50 years. Think about any other industry in this country that could get away with such a horrible performance record. You'd be embarrassed. This is true not only for electricity plants, but I think as you drive by any major industrial plant at night, you will see plumes. That is waste. We view it as an opportunity. We view it as profit. So 3 units of fuel, it's not improved since Eisenhower. Thomas Edison's initial power plants were more efficient than today's because Thomas Edison wanted to make money. And he realized he had 2 products. He had electricity, but he also had heat. And he could sell the heat to the nearby buildings. He was clever enough that he sold it to the New York Times and the Wall Street firms because he wanted good publicity and he wanted financing. But he understood that there were 2 products coming out of here and he hated waste. He wanted to be efficient. We have lost that sentiment. And the U.S. is horribly behind other countries. Particularly the Scandinavian countries and Germany and even Russia are well ahead of us in capturing both heat and power. Just to give a few examples of where the opportunities are. This is the ArcelorMittal steel facility in East Chicago, Indiana. The Chicago skyline is across Lake Michigan there in the background. Along here are a whole array of about 260 some odd coke ovens. Coke ovens are almost the size of this room. They're massive pits in which you bring in coal and you bake it, get out all the impurities, and you get coke. And coke then burns at a higher degree for your steel smelter. In the past, these ovens, not unlike the oven in your house, once you heat up the coal, the heat just rises. It goes off into the atmosphere, and you might be warming Lake Michigan, I don't know what you're warming, but it was waste. And a few years ago, ArcelorMittal realized that that waste had a value. So they put, with NiSource and actually a company that my boss was involved in at the time, they put heat exchangers and a variety of other things to capture that waste heat. They're now getting 220 megawatts of clean power simply from what had been wasted before. They're not burning any additional fuel. They're not emitting any additional pollution. They are capturing what had been a waste and creating clean energy. And not only does the environment benefit, because we've now got 220 megawatts of clean energy and we're reducing all sorts of greenhouse gas emissions, but Middle Steel is saving $100 million a year. They love it. They're able to survive in tough times that they wouldn't have had otherwise. This is a facility that we're now currently working on. This is a silicon manufacturer in West Virginia. To make silicon, you have these gargantuan pits with arc furnaces that heat up quartz rock, basically melted, so you get silicon at the bottom. As you can see here, you've got massive amounts of heat coming off these furnaces. They're at about 3,000 degrees. In the past, the company has had to spend a lot of money to try to cool down the heat before they put it in the baghouses, the pollution control equipment. Otherwise, it would burn it up. So they've got these elaborate little loops, and they're spraying water on it. They're doing tons of things to try to cool this down, because they view it as sort of a waste product that they've got to cool. We look at this and we think opportunity. So we're going to invest about $65 million at this place and gain about 45 to 50 megawatts of clean power. Again, not burning 1 ounce of additional fossil fuel. In fact, we'll be closing, this place had their own amazingly old and dirty coal plant at the facility. We're closing that down, not burning any additional fuel, not emitting any additional pollution. This plant, because it is now more efficient, and in fact, because we're going in there and we're redesigning the hoods of the furnaces, they're more productive than they were in the past. They're so much more productive and they're saving so much money, they're opening a 6th furnace, a new furnace on that facility. They're going to create 30 new industrial jobs in West Virginia alloy. And I guess my point comes back to, don't think of the climate debate as one of either, you're going to lose jobs. And it's not just the jobs in my company of creating all of this equipment. It's the industrial manufacturer. West Virginia Alloy, the silicon manufacturer, is going to be more productive than they were in the past. That's where the jobs are. And I think that's where we need to make our argument, that climate change, moving towards efficiency, move towards industrial productivity. Why is this important? As I mentioned before, if you look at it from this perspective, the generation of electricity and thermal energy, or heat and power, is about 69% of all fossil fuel CO2 emissions in this country. On a policy level, we spent almost all of our time focused on cars. I'm not saying we shouldn't have better fuel standards, we definitely should, but we're missing the elephant in the room. Why? I think it's largely because, to be honest, most of the environmental community and most of the policy community doesn't go to ArcelorMittal. They drive by that and they think, oh, steel facility. But that one steel facility is doing more clean energy than all the wind turbines throughout the entire Midwest. They're doing more clean energy because they're operating 24 hours a day than all those photovoltaic around the world that are connected to the grid. Don't ignore the industrial sector, is I suppose what I'm trying to encourage you. What are the barriers that stand in the way? Well, we've got these monopolists that control much of the grid. They're not often really wanting to interconnect with people that are generating electricity that aren't them. And so they try sometimes to put up barriers to interconnection, or to try to charge rather exorbitant rates for backup, for low rates to give power to the grid. Distributed generators do a lot of value to the grid. They reduce redundancy, they reduce line losses, they reduce the need for building new transmission lines, but you get absolutely no value for that. In basic economics, you would. We've got to finance our own construction. Most of the utilities, if you're going out currently to build a new power plant, they get a guaranteed rate if their regulators say it's okay. We've got to risk our own capital and raise it. And finally, I would argue that the environmental community has been amiss in realizing, of sort of being gods in thinking they need to just define what are the best technologies. I think it's always dangerous when government defines what are the best technologies. Since I said wind and solar and biomass that we liked, I think you need to define clean. What's clean? And then let any technology or any entrepreneur who can do clean, be part of a portfolio standard or tax credits or what have you. That's it. Thank you.